Assalamualaikum warahmatullahi wabarakatuh. As the title is here, climate change spurs new call for nuclear energy. Okay, basically, I will not advise you much to save the energy here through my lecture, but I will try to open a window which can give you more energy using less sources, so you can keep on clicking photographs unnecessarily in the Nasim Bagh or here itself. Okay, so you won't be worried much for energies. If we succeed in deriving energy through the means which I am going to discuss today, I call it nuclear energy. This is the 14th Energy Conservation Day today. So, in reference to this day, we are celebrating this. Okay, I have this plan here. We will revive what we have, sources in energies, and then I will go through nuclear energies through two processes, fusion and fission. Fusion is going inside the sun and whole universe is eliminated by just a single sun, because fusion is going on there. If other than fusion is going inside the sun will die out very soon, or it might have died and the universe would have been blind today, and nothing would have been visible. But this is a fusion they are going on. Very less amount is converted into a huge energy. Another is fission. The best example is an atomic bomb. A very small amount, just a kg or few kgs, is an atomic bomb, and world remembers Japan, Hiroshima, Nagasaki. And then there are myths about nuclear energy. I will also throw some light on it. Okay. So why you need energy? First of all, if we go back just petroleum era or coal era or gas era, people were living here millions of years, so-called. So they were doing their day-to-day jobs. As Professor Isa just said that there is a food security, land is narrowing down, but demands are growing up. That happened with us also, and we have looked up other means how we can generate more energies to meet the demands, to meet the challenges from the society. So why you need energy? For example, we are here today. If just this gas cylinder is ending up, this AC is switching off, we'll be in trouble. I am talking to you, you need to listen to me, I need to open my laptop, you need to watch this on projector, you need energy. So without energy, we can't understand today. So for like these things, you need energy for, even imagine a one single mobile which have been added per person in last 1 decade, and imagine the population of the universe. So you can guess how much the demand has increased by just adding a single mobile per head. And then there are other things. In the kitchen, we have added microwave oven, we have added ACs, we have added blowers, heaters, so there is a huge demand. So from society there is a demand, supply side has to manage this demand while taking care of the planet also. So once you need energy for running your appliances, you will look for sources, because whatever you need, you will look for sources. If you need money, you will look for a person who can give. You will not look for a person who cannot give. So you will look for a source. So where from you get it? You will think of the sources. There will be natural sources, and if you are not able to exploit them, as Professor Fayazab said, all energy comes from sun. Only thing is that we are not able to exploit it. Otherwise, huge energy every second is coming from the sun, but it gets lost. Either goes back or goes into the space. We are not able to harness it. Professor Altaf will talk about it. So you will look for sources, and the recent history mentions sources like this. We started with a cow dung. We could cook and boil waters at home. Even if today's life, if you go to villages, you'll see they'll be using cow dung. They'll make like those rotis in Indian village, you'll see. So these are coals, gas, petrol, etc. These are the sources. The second question which will come into your mind after discovering or finding a source, is it going to end up or is it going to be with me? Because it happens with money also. If you get salary every month, you look it. Is it going to end up soon or it will go till 28th, 29th? If it goes till 30, then it's okay. So you need to maintain that. So your question will be there in the mind. Is it exhaustive in nature or not? We have the problem with these conventional sources, petrol, coal, and gases. They are exhaustive in nature. So we don't want exhaustive kind of sources. This is another question for energy. So if you say that, let's say petrol ends up today, everything will go to standstill. Transport will end up, trains will stop, let's say, aeroplanes will shut down if just petrol or diesel goes off from the market. So they are going to define our life, everything. We are totally energy dependent now. You see, just your mobile gets shut down, sometimes the loss. Okay? We lose mental balance. Why it happened? Just a mobile. And if energy sources end up, what will happen? Okay, we have history that we did not stop. We started to walk, but with the progress in energy, we have switched over to horse. We could carry more load, and then to buses, then to trains, then to aeroplanes, and then space shuttles. This is our history, civilization. We have not been stopping. We are moving continuously very fast. So with the progress in energy, you see these kinds of things have been possible. These are in front of you. Everything is in front of you. There was time when man was just, transporting everything on his shoulders. But today you won't see. Okay, so there are two kinds of sources. One we call renewable and one we call non-renewable. One we call which is exhaustive in nature and one which is non-exhaustive in nature. These are some sources mentioned here. I need to talk today, I don't have a pointer here to focus that. I will be talking today about nuclear, which is here under the non-renewable category. But this is also, considered to be the renewable energy kind of source. Why? We will see that later. So nuclear is both renewable as well as non-renewable. So we'll see later why. So let's go with the first kind of sources which you have been using from centuries. For example, the non-renewable one is a coal here. It has an application in your kitchen, in heating of offices we see here in the university itself. But it has a disadvantage because we are linking today energy and environment, energy and climate, energy and earth. So this is the source, but it has a problem. It's exhaustive in nature, so it may end up someday. Even bigger mines are there. It's a local, it's not with everybody. It is in India, it is in Pakistan, it is in China, but it is not available globally and equally. So that is another issue which creates political instability. And greenhouse gases. A lot of greenhouse gases are emitted from these sources. When you use them, they are going to affect your environment. So this is the disadvantage with this. Similarly, from old times we have been using just directly wood for boiling water and cooking food and etc. This is energy, contains hydrocarbon, but it has also disadvantage. It's exhaustive in nature. Why exhaustive in nature? You may not be able to grow the plants at the rate as you utilize them for your needs. And there are some regions, say polar regions or deserts, where they don't have much forests or much plants to to meet this kind of source. And it is also problematic because of greenhouse gases as well as deforestation. This is our old kind of kitchen. It is the same wood-based stove. And then this you use gases. It is again exhaustive in nature, problematic, and greenhouse gases which affect the contain global warming issues, and it also creates political instability. Perhaps the recent wars in Syria, Iraq, and so on. They are because there were sources of this kind. And as far as the saving is concerned, for example, you cook some meat at home in the pressure cooker. What we do at home, we say that 3 cities, 4 cities, 5 cities, 10 cities. There is a number only. But the discipline to save the energy is that once one city is there, you just slow down the gas and maintain that temperature. Then you don't need to make it another city, third city, fourth city. What you do, you lose energy through vapors. Then you again maintain that pressure and that heat by utilizing more and more gas or whatever you have here, coal or so and so. This is here they make bread kind of this cow dung, and then it's being used, but it is again, this is global, although everybody has a cow or a buffalo throughout, but it is again greenhouse gas issue is there. Petrol, again same problems. These are the sources of energy. And okay, then hydro. Although hydro potential solves many problems, but it has its own disadvantages. Not working, huh?
Is it not working?
This. Okay. Okay. So then hydro, you will switch over from this was till now non-renewable energy sources. Let's move to renewable energy sources. Hydro potential is the first one. Although it's environmentally friendly, but it damages the ecosystem, and there is a loss of land, and the salmon fish is harmed because they need free flow water. And this is also local. Hydro potential is a good environmentally, better than the coal and petrol. Okay, so hydro potential is better than the coal, petrol, and so on. It's a clean energy, but it has also disadvantages, and this is a local source often. For example, in Kashmir, we have good electricity in June, July, August, and that time we don't need it much. But we need it now in the winters, but there's no discharge of water in the winter. Similarly, this is not available in Delhi, let's say, in plain areas. So it's available in hilly areas. So it's a local kind of source. It's not global. Everybody has no full access to this kind of potential. We call it hydro potential to generate electricity. So this is a dam. This is a water dam reservoir used to generate the electricity. This is shown here. I don't have to talk about this today. There are lots of things there. Then is a solar kind of potential we see in our industry also since last, I think, 5 years, almost all the roofs are covered with these solar panels. The issue with them is that they use materials, so there is an effect on the source. Again, solar material, silicon, and maybe now carbon nanotubes. And seasonal, I mean here, the disadvantage that, for example, Kashmir, often we see 3-4 months very cold, so it's not going to be efficient kind of source during winters, and cloudy it used to be here. And another issue is day-night. In the day you can generate electricity using solar panels, but in the night you cannot. So this is a disadvantage, periodic disadvantage attached to this kind of potential, solar potential. So it also consumes a lot of land. It is not that everywhere is a roof like we in Kashmir. People install these plants on the land, so it occupies a lot of land. That's another issue. And in deserts, the problem with the solar panel is that when they install solar panels, sandstorms come and cover all the surfaces. So you need regular cleaning and so for this also. So there are disadvantages attached to it. Why I mention a disadvantage? Because I have to emphasize today to the nuclear energy. So today I will accuse all of them with one way or other way, because I am going to praise today only the nuclear potential. Okay. If I would have been talking only solar, I will give many praises about it. But today I have to discourage about them. So this is another potential. We generate electricity using windmills. So you have, these are again local. Everywhere there is no good wind to generate electricity using wind potential. So you need to identify the sites. For example, in Jammu Kashmir, this is Riyasi. Good site is a Riyasi where electricity is being generated using windmills, and often it is around the oceans, because that ocean contains heavy vapors, water vapors, and they contain good mass, having good kinetic energy, and they are able to rotate these blades and generate electricity. Although it is a very cheaper and very clean, but the disadvantage is that it affects the birds. It kills birds and it affects their navigation. It's again local, so everybody cannot be benefited by this kind of potential. It's a local, some specific sites, and it is seasonal again. Sometimes there will be wind and sometimes there will not be wind. So you may have to adopt the power schedule cut. Okay, when there is a wind, there will be a power, and what happens often during wind is that electricity poles will fall down. So when there is a wind, so this is again issue with it. The other kind of potential is there are some volcano sites where earth is very hot. You just transport the water over there and convert that water into steam and rotate the turbine and generate the electricity. So this again local, specific sites, and you need to then have an installation system in picture to transport the electricity from this site to the towns and cities and villages. So power can be generated, but there are disadvantages associated to it. And biomass, it is not much efficient. It's not entirely clean also. It emits gases, it contributes to the atmosphere, and it may lead deforestation also. When you are using this plant, you will wish to run it on the, okay, you have to compromise that. You will go for the deforestation. You will bring the biomass, okay? So this is going to affect the atmosphere again. Now, this is here nuclear potential I am going to now touch. This will be coming up in the coming slides in detail, nuclear potential. So I'm just here, these are nuclear power plants, often located around water bodies. So it was also in the Japan. During the recent tsunami we have seen there was some accident with it also. They claim nothing had gone to the sea. So what we see here, I tried to put good sources in the form of a problem. Okay? Although they are good, but I presented them in the form of a problem. Now, once there is a problem, you will look for a solution. In the solution, your question in mind will be, it should be non-exhaust, first of all. So the source we are going to introduce, we will see that is that non-exhaustive or not. Is it global or local? So because everybody needs equally electricity, and then from the electricity you can run everything. So this is for the solution. You will look for a non-exhaustive kind of thing. You will look for a global solution, not a local one. And you will also wish to care for the atmosphere, that it should not affect the environment, it should have no pollution, and it should be cheaper. Everybody wishes these kinds of things. So they say Stone Age did not end up by the ending of stones, but by a better alternative. Stones are existing even now, but we are not living with those kinds of facilities. We have changed it because better alternatives came into picture. So demands are increasing exponentially for energy. Supply size has to be increased. Fossil fuels are not going to meet the challenge of present day world because of their own limitations and problems. Okay, they are local, they have political instability attached, and they have greenhouse gases. So this is going to be given up soon. Fossil fuel based energy is expected to be given soon with some better alternative. So the solution, okay, the solution for all of these desires which I mentioned here, from like this and this and this, the solution, okay, for the solution, my title of the talk arises here: Climate Change Spurs New Call for Nuclear Energy. So now I'll be going with few slides. I have some time now, good time, huh? Half an hour will be there. Okay, sir. Maybe now, again, this much time as I spent. So please focus. This is good time now. I have worked very hard these 2 days to prepare this lecture. You also be little serious to get something, and I expect good questions from you. Please, you take tea comfortably, but don't talk in between. See here. So now we are going to put up the solution for the problems, and I propose the solution through nuclear energy. Okay. So immediately the solution is fission process. But this is not going to live long. The long-term solution is fusion process. So I will be now talking about nuclear energy through two processes: fission process and fusion process. Fission process, the best example is atomic bomb, and the fusion process, the best example is sun shining every day and night. Sun is shining day and night, please. Okay, it's we see only it in day, but it is otherwise shining continuously. So nuclear energy, it uses very small quantity and produces much energy. That's a good thing about it. We will put some comparison soon. So these are some nuclear power plants. These are nuclear plants here and there. Often they are cylindrical in shape. Let me leave that for students. Either you ask me why they are cylindrical in shape, or I will ask you at the end. So, going to begin with the nuclear potential. How nuclear energy is released and exploited for meeting our needs. So there are two processes going on. One is a fission. I mean, fission is naturally often not occurring naturally. You need to induce it. So we will have a high energetic neutron on some stable nuclei like uranium-235, 235 is its mass. Atomic number is 92. That's you people know, hopefully. So it's a neutron. It's a uranium. When you induce it or excite the uranium, it's going to disintegrate into fragments like krypton and barium, and then other neutrons. Other neutrons are very useful to create a chain reaction. The way we created reaction first by using our own neutron, and then later on that reaction will be self-steady. Okay, these neutrons will maintain the reaction onward and the plant will run. That we will see later on. So this is a fission process. And another process is fusion, where lighter nuclei, say hydrogen, deuterium, tritium, will fuse, combine each other, break down the Coulombian potential, proton-proton repulsion, and form a bigger nuclei and some other particles, so helium and other nucleons. And in both the processes, while going through fission or while going through fusion, a lot of energy is released. Mega million electron volts. We'll see that how later. So this is the beginning. So there are two processes, fission and fusion, which we declare under nuclear energy. So why they will go through fission and why they go through fission? This is physics oriented. You will see that till some 20 atomic number, starting from hydrogen, helium, lithium, carbon, oxygen, nitrogen, the proton number and neutron number is equal. For example, carbon is 12, C12, so it contains 6 protons and 6 neutrons. But later on, when you go for bigger, heavier elements, you will see proton number is more than the neutron number. Neutron number is more than the proton number, because protons being positive charged, there is a Coulombian repulsion. It will try to destabilize the nucleus, break down the nucleus. So to compensate that, neutron number increases and nuclear force dominates, so nucleus is stable. So if there is any deviation, finally we have this curve, blue here. Among these, this we call, later I will go to second here, we call it a stability curve. So more neutron number when you go for higher, heavier elements is a more stable. But if you go down, less neutron numbers is unstable. So it's easy to go through fission. It will break down into other smaller particles. So this is the reason here why fission and fusion occurs. We have a binding energy curve. For example, here around 40 is a iron. Iron is a very much stable system, bound system. But if you go beyond this here, say uranium is 92 here. 92, binding energy is decreasing, so it's easily fissionable compared to this guy, where it is high, it is decreasing. And the lighter elements here, hydrogen, atomic number hydrogen, helium, lithium, they go to fusion. So lighter elements go through fusion and heavier elements go through fission. So two processes, both the processes release energy, huge energy. So this process is going here in the sun and this process is going in the atomic bomb. Okay, so this is a definition of fission. Fission is a splitting of bigger atoms into smaller ones and releasing energy. This energy we need to harness. The smaller ones are quite stable, better stable to go for more fission processes. This doesn't occur naturally, normally, but it needs some ignition, and that we will be using a neutron. So you use here neutron. A bigger nuclei is being hit upon by a neutron, high energy neutron. It deforms its shape and then little by little breaks down into two, releasing another kinds of neutrons. These neutrons in further will create avalanche kind of reaction and keep on making more and more fissions and more energy. We call that chain reaction. This is a chain reaction shown. One neutron hitting upon a uranium, breaking it into calcium and rubidium, but in turn it releases 3 more neutrons. These 3 neutrons will generate because the matter is already present there. They will hit again this uranium and in further release more neutrons, and this will be a chain reaction. If this reaction is controlled, you will get a power plant. If this chain reaction is not controlled, you will get an atomic bomb. So wherever you have a nuclear power plant, every nuclear power plant will be converted into a bomb if this reaction is not controlled. Okay, even if you have 1 kg or 2 kg uranium over there as a fuel, but if this reaction is controlled, so power plants are just a controlled bomb. They are controlled bomb. While as the atomic bomb, they allow there that in a fraction of second, the chain reaction takes place. One atom releases 3 neutron, 3 will release then 9 will go to 3 to the power 333. So in a microsecond of kind of time, a huge blast will occur. That is Hiroshima, Nagasaki. Okay, so this is an example. For example, just a 1 atom uranium, when it goes through a nuclear reaction, it's releasing energy. How much energy? Okay, so this is a number of neutrons you have to control for making it a bomb or making it a power plant. If you control this to k is equal to 1, it will be a stable power station. But if this goes to 1, k is 1 means more and more neutrons and more fissions. So it's going to be a chain reaction and it's going to be a blast. Here it is again shown as a chain reaction. Uranium breaking into 2. This star is an energy, huge energy. And then this again breaks into 2, energy. This breaks into 2, energy. This energy, this energy. So we call it first generation, second generation, third generation, because initially we used our own neutron, and then later on the reaction itself maintains the reaction by using its own neutrons for running this. So the energy is calculated using Einstein's mass energy relation. If you see the mass of reactant and mass of product here, very small mass defect is observed, but multiplying it by c square, it's very, very huge. The comparison is given here. For example, 1 kg of uranium, 1 kg, just 1 kg. You don't need to use a whole forest. 1 kg of uranium is giving us as much as energy as 20,000 tons of a chemical explosive trinitrotoluene. So 1 kg is, so because of this we say sometimes it's a renewable. It is using very small amount, 1 kilo, 2 kilo, and giving you energy of billions of gallons of petrol, coal and other kinds of things. So you don't need 1 kg, you may need a microgram to run a power plant. Okay? So, and it will be slowly going on for a year or 2 years. Maybe 1 kg, 2 kg in 1 year or 2 years, you will generate huge electricity. So this is another example how mass defect is converted into energy. This is another from the fission. For example, this mega electron volt. While as if there is chemical reaction, it will be just a milli electron volt or electron volt. Okay, this is another example of the energy released through nuclear reaction. 10 power 8 electron volt. It's a huge. It's a 100 million electron volt by just 1 atom. And imagine then 1 gram. Okay. So I am again on the fission still. I have few slides for fusion also. Please just have a patience. So fission, if you don't control the chain reaction, neutrons, you will have this kind of Hiroshima kind of things. Okay, how you use this now, this energy? The principle is same. The principle is the way you generate electricity from hydropotentials. You just use water there, which is at high height, having potential energy due to height. You convert that through pipes into kinetic energy and rotate the turbine and generate electricity. Same is the case in wind. You use wind to rotate the turbine and generate electricity. And geothermal, same. Coal, you use coal to generate steam in the train or in the power plant, and similarly petrol engines we have at home, they just generate the power through turbine. Same is the principle here also in the nuclear power plant, because this heat is used to generate steam and produce electricity. there is a law. This all electricity, whether through hydro potential, through wind potential, or through geothermal potential or nuclear plant, it works on Faraday's laws of magnetic induction. Faraday's law is whenever a conductor is placed in a varying magnetic field, you need to vary the magnetic field. So you use water there to rotate the turbine, change the magnetic field, and wind or steam. Okay, you use this to rotate the turbine, rotate the magnetic field, and produce the current. So it all works through Faraday's laws of magnetic induction. So everybody have the same principle. Whether it's a steam, whether it's a wind, whether it's a water, they rotate the turbine and generate the electricity and supply to the homes. So this is a here nuclear power plant. Here is a fuel, nuclear fuel, say uranium. A nuclear reaction occurs here. It is in the middle of a water, and huge energy is released. That energy heats up this water. We call it coolant here, and it's going to be supplied to turbine here, steam as a steam. This will rotate the turbine and generate the electricity. Principle is same as in hydro potential. These are some requirements for a nuclear power plant. You need a fuel, that is uranium. You need control rods so that it will not become a bomb. So it restricts the neutron number so that the chain reaction will not occur. Chain reaction is a bomb. Okay. So there are two types of nuclear power plants. We have one light water reactors and another is a boiling water reactor. Let me not put much force here, maybe to catch your attention for a longer time is difficult. So let me go for fusion for just few slides. Fusion here. Because fusion is basically a future. Fission is also a trouble because it's a radioactive material. Waste management is an issue. So let's go now to fusion. Fusion reaction. Okay, just a few words on fusion. Fusion, for a fusion to occur, means combining small lighter elements, you need at least 1,000,000 degree temperature. So on ground, it is not easily possible. In sun, it occurs, okay? In the core of a sun, gravity tries to collapse the all material of sun at center. So this produces this gravitational pull. So when it combines hydrogen gas together, so it breaks down the Colombian repulsion, and then a temperature is raised up, okay, in the core of the sun. That goes to 1,000,000 degree and a fusion takes place. And fusion pushes it back, sun. It avoids its collapse, otherwise sun will disappear. So fusion pushes the gases outside and gravity tries to put the gases at the center. So there is always a fight between a fusion and gravitational pull. So this fight is the life of a sun and life of we people here. Okay. So that comparison is there, competition is going on there. So in the sun, this is going on. Hydrogen meets and gives energy. This is going on. Gravity tries to collapse everything at the center, but fusion pushes it back outside. So a balanced size and structure of the sun is existing. Let me leave this comparison also. This is fusion. So the question is how we okay, as I said that future is not for fission as far as the nuclear energy is concerned. This is my last point to focus. The future energy is not a fission-based nuclear power which is presently existing everywhere, because you don't need 1,000,000 degree temperature to run a nuclear power plant which is working on a fission kind of reaction. But for fusion, you need a 1,000,000 degree temperature. So that is not possible on Earth at ordinary conditions. But what we do, we use some kinds of, I have wood here, we use laser beams and create plasma fluid on some target. So for example, this green is a laser light. It hits upon some metallic target here. So this laser light, which is very intense, 10 power 8 megawatt, okay, contains huge energy in a short pulse. It's able to eject out some or etch out some material here as well as ionize it and make it a plasma. Plasma is a mixture of electrons, ions and neutrons. So, and the temperature of plasma is 1,000,000 degree. Temperature of a plasma is 1,000,000 degree, which we need for fusion reactions. So easily now it has been made available to generate plasma which is of 1,000,000 degree temperature, and there you can convert it into a power plant based on fusion reaction. But big problem is that the lifetime of this plasma plume is 1 microsecond. Okay, lifetime of this plasma is 1 micro. So you will get a fusion based power plant, but it will work only in a 1 microsecond. And then you need to send another laser beam and have again power for again 1 microsecond. So presently scientists are working to enhance the lifetime of this plasma plume. So since it's a charged, so they use magnetic coils. Magnetic coils will not allow this charged species to get lost over the chambers. They will allow it to recycle, circulate in around some center. So presently in India, there is IPR center. I have visited there in Gandhinagar. They reach it to 1 second, and in other countries I found they reach it to 3 seconds, from microsecond to 3 seconds. And if we are able to reach to sustain this plasma for 1 day, 1 month, 1 year, then it's a free power for everybody based on fusion reaction. So future is for this, but the challenge is to have this longer life. Okay. Okay, then advantages are there. No carbon emission. Okay, very small fuel is used and billion times energy. Let me take just 2 minutes, please. So this you will read yourself. There are some myths again which needs to be addressed, that nuclear power is dangerous, and there can be some kinds of nuclear weapons. But the results prove that when Hiroshima and Nagasaki happened in 1995, that time there was no nuclear-based power reactor. So that thing and this thing is different. Okay, France has many highest number of nuclear reactors, but no atomic nuclear bomb. So this is contrary to that. There is a waste, but it's a very small waste. It can be dumped under some tunnel easily compared to the biomass and other kinds of things. Okay, this is Indian nuclear power scenario. You can read them that they have an atomic power plant here in Narora, Rajasthan, this is near Aligarh, and some power plants are there. So finally, conclusion is that it's a reliable, it's zero emission, it's promising future energy, and it contains high energy density. It doesn't pollute as well as, okay, this point. Finally, let me go.